Next section is 14.4, differentiability in tangent planes. So if you have a surface right, if we have some surface, let's say this is the graph of z equals a function of x and y. And let's go ahead and put some grid curves on here. There we are, something like that. So at a certain point on the surface, right here, if we imagine zooming in, like really, really far, let's say really close, zooming in really close, then effectively the surface is indistinguishable from some plane. Okay, let's call this point P. So the point P is this point A comma B. So at this point P, provided your surface is differentiable, which in this class we do work with them, then if we zoom in, a surface it becomes indistinguishable from its tangent plane. And it just so happens that for the equation of the tangent plane, these will give us everything we need to write down this equation. So in particular, this normal vector is something like fx, fy, -1. So that's our normal vector. So if we cover up this last term, this is really similar to the equation of the tangent line in Calc 1. In Calc 1, we would say something like y equals f of a plus f prime of a times x minus a. So we have our change in x, rate of change in the x direction, our y value on the curve, and then y equals. Well, here the output variable is z, so instead of y we have a z, but we still have the value of the function. We have the rate of change in the x direction times our change in x. The only difference here is we have two independent variables, so we also have to take into account the rate of change in the y direction and the change in y. But these two things are very similar. And that's the equation of the tangent plane. This idea, linearization here, this is the idea so essentially linearization means equation of tangent plane. Okay, so what this is saying, if you have your actual surface, so this right here, we can think of this as the actual surface. And then this right-hand side here is this equation of the tangent plane. If we imagine picking up this tangent plane and moving it right here, okay, if you zoom in really close, the surface is indistinguishable from the tangent plane if you zoom in sufficiently far. And that's all this approximation is saying. This approximation is saying the surface is approximately equal to the plane, provided that your change in x and y, so how far away you move from the point AB. So the point AB, well, A comma B comma f of AB, is the point on the surface, the point of tangency. So if you don't deviate too far from that contact point of the tangent plane, then the surface is well approximated by the tangent plane.